So we're going to start dealing with measurements, or a term that we like to use is called size. It's important to understand how measurements are compared to each other, and I'll give you one example. So if everything on this little chart going to the right is bigger, then the smallest size that we use is like an inch. Okay, I know we use centimeters and stuff like that, but we're talking just the English system. Well, if we're looking for something that's bigger than an inch, well, we know that inches become feet. And then feet, well, they become miles. And then miles can become other things, you know, like light years or things like that. So the idea is that this is going to continuously go on. It's important to understand how things compare to each other. So like we know that ounces, you know, are smaller than gallons. That's an important thing to understand. And so as we're working through really the next like 2 to 3 sections, make sure you have this stuff written out so that you don't have to go look it up every time. It would definitely make it a lot easier for you. Okay? So, if we're dealing with the height of a classroom, we got to think about which of these things would be most realistic for a height of a classroom. Well, I'm looking at my classroom right now, and you guys, if you're watching it in school, you might be too. We know that 12 inches, well, that's like the size of a ruler, so that doesn't make any sense, so that's got to be out. But 12 yards and 12 feet, we got to figure out which of these is bigger. Well, we know that on a football field, a yard is equal to 3 feet, so that this would actually be 36 feet. And that seems really tall. So which one of these would be more realistic for the height of the classroom? 12 feet. And that's exactly how you're going to do these estimations. So under here, we have the weight of a basketball. Well, first of all, I'm looking at 3 miles. That's not weight, so that's out. But then we have 3 tons, ounces, or pounds. Well, an ounce is very, very small, very little. A ton is really, really big, and then a pound is somewhere in the middle. Well, I hope that we understand that 3 tons, that's too big. That's like 6,000 pounds. It's very heavy. But 3 ounces, that's probably too small. Therefore, the answer should be 3 pounds. Okay? So that's how you do that with the English measurements. We're not going to do a ton more examples because I think that the iExcel does really well at coming up with good examples. But we're going to now deal with the metric system. So the idea in the metric system is that this is the standard measurement. A meter, a gram, a liter, whatever they're using as their current measurement, that's what we call the standard. And the 3 that we're going to work with the most are kilometers, centimeters, and millimeters, or in this case, kilo, centa, and milli. And they compare to each other. We know that if a meter is 1, a kilo stands for 1,000. But everything is going to go bigger as we go right, so going left would make it smaller. So that this is actually 1/100th of a meter, and a millimeter is 1/1000th of a meter. Okay? So for like, if we're trying to make a kilometer, we multiply this number times 1,000. But if we have this number we're trying to make a centimeter, we divide by 100. Okay? So meter can be reversed with anything. So I could make this gram instead of meter. That would make this a gram, and then this would be a kilogram. Therefore, a kilogram is 1,000 times bigger than a gram would be. Okay, and that's how the metric system works. And you actually will have a nice activity to break that up, and then we'll do a lot more with it over the next section. I'm hoping that you've seen it before, that it's not totally new. But if it is, we will go into a lot more detail. So, going back to our examples, We have the weight of an elephant. So we have 4,000 grams, kilograms, centigrams, or milligrams. And which of those makes the most sense? Well, we know that by size, milligrams is smallest, centigrams is second smallest, grams is third smallest, and kilograms is the biggest. Well, 4,000 milligrams, well, a milligram is very, very tiny. 4,000 of those is still pretty tiny. Centigrams, same idea. That's still really small. Okay, and we're looking for the weight of an elephant. Now, 4,000 grams. So we go back to our chart. We know that 1 kilogram is going to be equal to 1,000 grams, because it's 1,000 times bigger. That means that 4,000 grams is going to be equal to 4 kilograms, which is actually not that big. That's like 8 pounds. Therefore, that's out. So it has to be 4,000 kilograms is most realistic weight for an elephant. Down here on the bottom, same idea. Length of a football field. Now this time we have 10,000 meters, kilometers, centimeters, and millimeters. And here's the other way you can solve these. I want to turn these all into that common measurement. So I have 10,000 meters. Well, 10,000 kilometers, we take that number times 1,000, so we'd add 3 more zeros. So that's 10 million meters. That's huge, so that's out. 10,000 centimeters, well, we divide this by 100, and that becomes 100 meters. That seems pretty realistic. Let's check the last one. 10,000 millimeters, we divide that by 1,000, and we get 10 meters. So our options are 10,000 meters, 100 meters, or 10 meters. Well, this one's too big. And then I think this seems more realistic because that's the length of a track, which is about the length of a football field. Okay, so you just kind of break those up. We'll get more into conversions in the next section, but for now, I want us to deal with just estimations. So we have an activity. Make sure you ask me about that in class, and then you'll have a couple IXLs, and then we'll get into the more difficult stuff next.